The quantum world is typically modeled as a blur of probability, but if we introduce classical gravitational ripples into this space, that cloud collapses into a rigid, sharply defined geometric orbit. Standard physics ignores these gravitational forces at the microscopic level. The assumption is that their intensity is far too low to affect subatomic particles. The physics of unity framework argues the exact opposite. These gravitational waves are the primary mechanism generating the features we attribute to quantum mechanics. To understand how, we return to the foundation of classical gravity. Einstein's equations for gravitational waves, specifically when evaluated in linear approximation, contain the exact mechanics required for this framework. If we want to understand particle motion at this scale, we must stop treating gravity as a macroscopic afterthought and recognize it as the strict boundary condition governing the quantum world. Consider a standard problem in classical electrodynamics. An electron oscillating in a vacuum generates an electromagnetic self-action force. This force creates drag, making free, sustained oscillation impossible. The solution lies in the universe's macroscopic mechanics. As the electron moves, it triggers a gravitational response from the surrounding universe. This gravitational force acts in direct opposition to the electromagnetic drag. When we map these opposing forces, we find an exact equilibrium. The mass from the electromagnetic response equals the gravitational response, bringing the net force to zero. While it is true that gravitational radiation is extraordinarily weak across most frequencies, its intensity spikes dramatically at the precise frequency of the electron's oscillation, matching the electromagnetic force. This permanent, perfectly balanced oscillation forms the baseline state of reality. It is a strictly mechanical layer of physics known as the pre-quantum vacuum. When evaluating the equations for these gravitational waves, the mathematics yield multiple valid kinetic solutions. This indicates our universe contains a more complex architecture than a single unified reality. Our familiar reality operates under standard thermodynamic modeling, governed by the Boltzmann equation. The framework posits our universe is a unity of four interconnected worlds, differentiated by the direction of time and causality. World 1 operates under standard, forward-moving Boltzmann kinetics. The other three operate under anti-Boltzmann kinetics, where time and causality are reversed. Because these worlds are mathematically linked by the same gravitational equations, an oscillating electron has the physical capacity to transition across these boundaries. As electrons move between these spaces, we have to track their distribution. We assign a particle density value, denoted as ρ, to map the exact number of electrons present in each of the four quadrants. The electron is not materializing and vanishing through random chance. It is navigating a rigid, perfectly defined four-part geometry of causal realities. We can track the particle's movement directly. As the electron weaves through the grid, it continually updates the distinct particle densities, ρ1, 2, 3, and 4, for each respective world. The stability of these four interacting distributions is what physicists traditionally refer to as the wave function. Transitions between these worlds are dictated by the geometry of the electron's rotation. Because their gravitational tensors align, World 1 and World 3 couple into a single density, forming the real portion of the wave function. World 2 and World 4 form a perpendicular coupling on a different causality axis, appearing as the imaginary component. This presents a sharp contrast to the standard interpretation of quantum mechanics, where the wave function is viewed nearly as an abstract mathematical tool used to calculate probability. In this framework, the wave function is a literal field. It generates smooth metrics directly proportional to the number of particles, behaving mechanically as a form of gravitational energy. These complex numbers map the literal coordinates of parallel kinetic geometries. This interworld geometry relies on a mechanism called the gravitational energy loop. The energy is maintained through interactions between wave functions originating from worlds with conflicting arrows of time. When calculating the limits of these interactions, the addition of time behaves inversely, depending on which temporal direction a specific world dictates. Physically, this creates a temporal echo. Crossing into a reverse time world, the electron's trajectory loops backward along its timeline. In a cross-section of this moment, the timeline is intersected multiple times, meaning multiple physical copies of the same electron exist simultaneously. Because the particle is locked in a continuous oscillation between the four worlds, the total number of these temporal copies fluctuates continuously. This fluctuation maps exactly onto established models. The oscillating density of these temporal copies is mathematically identical to the function of de Broglie waves. Wave-particle duality is the observable effect of a single particle echoing back and forth across its own timeline. This single temporal loop does not exist in isolation. It cascades rapidly, duplicating into a massive, interconnected network of orbital circles. Every change in trajectory occurs at the precise distance of the Compton wavelength, generating a vast array of distinct circular paths. Within this local web of electron transitions, there are roughly 10 to the 20th power distinct concurrent circles. When we calculate the sum of the particle densities across this entire network of four world loops, we arrive at the exact equilibrium condition defined by the Schrödinger equation. The term IH bar deep psi dt calculates the raw gravitational waves echoing through this 10 to the 20th power structure. We began with what classical physics considered an impossible free oscillation, and found that the universe's macroscopic gravitational response balances the equation perfectly. The imaginary numbers required to make quantum mechanics function physically represent inverted causal worlds intersecting with our own. The wave-like behavior of solid matter is simply the constant fluctuation of a single particle intersecting its own local timeline. Every wave-like movement is a trackable, deterministic intersection of these four worlds. At the quantum level, probability dissolves into the mechanics of this multi-world machine, powered continuously by inter-universal gravitational waves.